Researchers may have solved the ancient mystery behind the building of Egypt's majestic pyramids. Scientists made an incredible discovery which may explain the construction of 31 pyramids, including the world-famous Giza complex, which were built in Egypt more than 4,000 years ago. A team from the University of North Carolina, Wilmington, has revealed that the breathtaking ancient megaliths are likely to have been built along a long-lost ancient branch of the River Nile. The lost waterway is now concealed by layers of sediment underneath desert and farmland. It has been a working assumption for many years that the ancient Egyptian civilization must have used water to transport huge blocks and other materials needed to construct the pyramids. But archaeologists have not been able to find any such body of water until now. Professor Iman Gonheim, who is one of the new study's authors, said, "Nobody was certain of the location, the shape, the size or proximity of this mega waterway to the actual pyramid site." The team used high-tech resources such as radar satellite imagery, as well as more rudimentary tools such as historical maps, geophysical surveys and sediment coring to plot the path of the sunken river branch. They believe it was buried by searing drought conditions and swirling sandstorms thousands of years ago. Researchers were able to penetrate the sand surface and produce images of hidden features using the radar technology, according to the study published in the journal Communications, Earth and Environment. They found buried rivers and tantalizing ancient structures running at the foothills of where the vast majority of the ancient Egyptian pyramids lie, Professor Gonheim revealed. In an interview with the BBC, Dr. Suzanne Onstein, another of the study's co-authors, said, "Locating the actual river branch and having the data that shows there is a waterway that could be used for transportation of heavier blocks, equipment, people, everything, really helps us explain pyramid construction." Researchers found that the river branch, named the Ahramat branch, was around 64 kilometres or 39 miles long and between 200 to 700 metres or 656 to 2,296 feet wide. The lost waterway bordered 31 pyramids which were built between 4,700 and 3,700 years ago. They say that the discovery could explain the presence of so many pyramids between the famed Giza site and Lisht, where the Middle Kingdom burials took place. The area is now part of the arid and inhospitable Sahara Desert. The paper, entitled "The Egyptian Pyramid Chain was built along the now abandoned Ahramat Nile branch," said that the river being adjacent to the pyramids was active and operational during the construction phase of these pyramids. Dr. Onstein added that the ancient Egyptians could use the river's energy to carry these heavy blocks rather than human labour, therefore requiring a lot less effort to move them. The paper's abstract read, "The largest pyramid field in Egypt is clustered along a narrow desert strip, yet no convincing explanation as to why these pyramids are concentrated in this specific locality has been given so far. Here we use radar satellite imagery in conjunction with geophysical data and deep soil coring to investigate the subsurface structure and sedimentology in the Nile Valley next to these pyramids. We identify segments of a major extinct Nile branch, which we name the Ahramat branch, running at the foothills of the Western Desert Plateau where the majority of the pyramids lie. Many of the pyramids dating to the Old and Middle Kingdoms have causeways that lead to the branch and terminate with valley temples, which may have acted as river harbours along it in the past. We suggest that the Ahramat branch played a key role in the monument's construction, and that it was simultaneously active and used as a transportation waterway for workmen and building materials to the pyramid sites." In conclusion, the paper read, "The present work enabled the detection of segments of a major former Nile branch running at the foothills of the Western Desert Plateau, where the vast majority of the ancient Egyptian pyramids lie. The enormity of this branch and its proximity to the pyramid complexes, in addition to the fact that the pyramid's causeways terminate at its riverbank, all imply that this branch was active and operational during the construction phase of these pyramids. This waterway would have connected important locations in ancient Egypt, including cities and towns, and therefore played an important role in the cultural landscape of the region. The eastward migration and abandonment of the Ahramat branch could be attributed to the gradual movement of the river to the lower-lying adjacent floodplain, or tilting the Nile floodplain towards the northeast as a result of tectonic activity, as well as wind-blown sand incursion due to the branch's proximity to the Western Desert Plateau. The increased sand deposition was most likely related to periods of desertification of the Great Sahara in North Africa. In addition, the branch eastward movement and diminishing could be explained by the reduction of the river discharge and channel capacity caused by the decreased precipitation and increased aridity in the region, particularly during the end of the Old Kingdom. The integration of radar satellite data with geophysical surveying and soil coring, which we utilised in this study, is a highly adaptable approach in locating similar former buried river systems in arid regions worldwide. Mapping the hidden course of the Achramat branch allowed us to piece together a more complete picture of ancient Egypt's former landscape and a possible water transportation route in Lower Egypt in the area between Lisht and the Giza Plateau. It added, revealing this extinct Nile branch can provide a more refined idea of where ancient settlements were possibly located in relation to it and prevent them from being lost to rapid urbanization. This could improve the protection measures of Egyptian cultural heritage. It is the hope that our findings can improve conservation measures and raise awareness of these sites for modern development planning. By understanding the landscape of the Nile floodplain and its environmental history, archaeologists will be better equipped to prioritise locations for fieldwork investigation and, consequently, raise awareness of these sites for conservation purposes and modern development planning. Our finding has filled a much-needed knowledge gap related to the dominant waterscape in ancient Egypt, which could help inform and educate a wide array of global audiences about how earlier inhabitants were living, and in what ways shifts in their landscape drove human activity in such an iconic region. But that's it for this video. Don't forget to like, share, and most importantly subscribe. And you can also support the channel on Subscribestar via the link in the description, or via YouTube Super Thanks. Thanks for watching. Bye for now.